This is Devi Chokapila, Assistant Professor from the Department of Computer Science and Engineering. And today in this lecture, we are going to learn about the string matching using brute force technique. So after completion of this lecture, student able to understand the concept of string matching problem, and they can match the pattern from the given string using this brute force technique. So let's start with the string matching problem. Then we'll see the brute force algorithm to solving this particular problem. And we go with an example and we'll see how you're going to match a pattern from a given string. So this is a problem. Actually, we have to take a string which consisting of n number of characters. And then we have to take a pattern which is a length of m that consisting of m characters, and we are trying to match this particular pattern with a string. So now what your brute force string matching algorithm will say is it is type forward technique, right? So what it is going to do is it is try to match the pattern from a starting character. So from character by character, it is going to match. So the first character of the pattern is going to match with the first character of the string. So if any match is found, then the character is going to be incremented and it is trying to match with the second character of your pattern with the second character of the string. So like this way, it is going to match the entire pattern from a given string. So if any of the character from the pattern is not matched with the string, then the position is going to be incremented. Again, it starts the same process until either it finds the pattern from a string or else it exit no pattern in a given string. So let's we see the problem statement, like the given a string of n characters, which is called as a text, and a string of m characters, which is called as a pattern. So find a substring of a text that matches the pattern. So to put it more precisely, we want to find ith index of the leftmost character of the first matching substring in the text. So such that, so like you are considered ti. So ti is nothing but at ith position of the text. So now you're going to take a pattern. So pattern at ith position, you're finding your pattern. So there you're finding your pattern. Then it is going to take a character by character, right? So it will be take a text from I plus j position. So j is nothing but the number of characters of your pattern. So now here in this representation, you can see this is your text and this is your pattern. So for simple understand, text is represented with T and P is represented for pattern. So now you start with T naught, T1, T2, T3 and so on, Tn minus 1 because we have n number of text characters, and then we have pattern. Suppose see at ith position, the first character of your pattern is going to match. So then what it is going to do from this position, it is going to match with the remaining characters of your pattern with your text. So if a match is found, then it returns the position where it finds the first occurrence of your pattern. So otherwise it returns false and it simply says that the pattern is not in your given string. So let's move on to the string matching algorithm of brute force technique. So this is an algorithm and algorithm name is searching for a pattern. So it will take two arguments. So one is your pattern and another one is your text. So we already discussed like pattern is having the length of m and your text is having the length of n. So pattern is represented with p of 0 to m minus 1 and text is represented with 0 to n minus 1. So this is your brute force string matching algorithm. We'll take these two as an argument. And now here we simply implement a brute force string matching technique. And then the input we are taken as the text of characters n and the pattern of characters m. So now what will be the output? So the index of the first character in the text that starts a matching substring of substring, or it returns minus 1 if the search is unsuccessful. So now you can see here, so for I is 0 and it is none up to n minus n because we are not seeing up to the last character, because we know like once you search for the last character, so that is the first character of your pattern. Suppose in case it is going to match. So the remaining characters we cannot see from the end of your text. So what simply we have to do is we have to reduce, means we have to subtract the length of your pattern from the length of the text, and we are going to run your I loop up to that only. So for that, we have to save some time. And your J is going to run from 0th index only, because we need to match from the first character of your text to first character of your pattern. We'll start searching from there. So while I is less than, J is less than M, and P of J equals to P of I plus J, we have to increment the J. If J equals to M, then return I, means it is a condition where we are finding your pattern from a string. So else, so if you are not finding any pattern in your string, simply what we have to do, we have to return -1. That simply says unsuccessful pattern search. So this is a simple example for string matching. Suppose see here, we are taken a string as nobody noticed him. So this is a string which is a length of n, and the pattern is given as not. So now what simply we have to do, we have to find the NOT is available in your string or not. So by using brute force technique, what simply we have to do, so we have to compare character by character. Okay, so see here. So first our pattern is NOT. So now what we have to do here, see the I is 0th position and your J is also from 0th position. So now these two characters is going to match. Yes, it is successful. So then what's happening? So now your I and J is get increment and it is going to check for the second character. Yes, it is also match. So now it is going to check for this. Okay, so now your J get increment, it will take this position and it is going to, it is trying to match with that. So what simply we are finding? So here we find that, so this B and T is not matched, right? Even these two characters are matched, but this character is not matched. So because of that, this pattern is not at this position. So what simply we have to do? By algorithm, what simply it has to do? See here, so we start J, and when J is get incremented, so now it will take I plus J the position up to it is going to increment. Okay, so this position, if you find that J and M if both are equal, then it says that is a particular string we are trying to match. But this condition fail, right? So simply what we have to do, we have to increment the I position. Okay, so see here, that's what's happening here. So now I get increment. So for the next position, what you're trying to do. So here we are going to match with this. So this is not match. Okay, so now again, it is going to be incremented. So now it is trying to match with. So here also N and B is not match. So again, your it's get increment, right? Your I get increment so that it is trying to match with 0. And here also we are not finding any match. And now again it get increments and it's trying to match with D. So here also not match is found. So again it get increment and it will take the next position and it tries to match with Y. So here also no match found. So again it is get increment and it is trying to match with underscore. So here also the characters are not match. So again, that position is going to increment. And now here you can see the first character of your text and pattern is matched here. Okay. And then, so now it will take the next position of your text as well as the next position of your pattern. So now these two get compared. Yes, we are seeing that O and O is get matched. So now again, these two get increment and it is going to match with the next two characters. And at this position, you can see that the pattern of your given text is matched at this particular index. So what is this index? So this is the index of 0, 1, 2, 3, 4, 5, 6, and 7. So this is the 7th index of your given text and you started matching of your pattern. So what your algorithm is simply returns, it returns the index 7. because the match is found here. Okay. And then it will return the index. So in this way, we are going to match the pattern from a given string by using the brute force string matching algorithm. And coming to a time complexity of this particular algorithm, so it may have to make all m comparisons, because see here in this example, so here we have to do these many of comparisons, because here we can see the partial part of your pattern is going to match with your text, but the entire pattern is not matched there. So like that, we have to make all m comparisons before it shifting the pattern, right? So see here the pattern is shifted actually. Now you can see here up to this pattern is not switched, but here we can see the pattern is shifted. See here also the pattern is shifted, and here also the pattern is shifted, and here also, here also. So these many times we shifted the pattern, means before we are going to match it. So, and this can happen for each of n minus m plus 1 tries. So we are making these many of tries. So in this worst case, so either we come up with the pattern which is masked from your text, or else we can see up to the end of the text and we can declare that pattern is not masked with your text. So the time complexity we can say is a multiple of your text with the pattern. So that is theta of nm. So this is a worst case time complexity of string matching algorithm. So I hope you all understand this particular topic. Thank you.